What do you get when you cross a snowman with a vampire? Frostbite. Hey guys, so number 5. You attempt to push a table with a force of 500 newtons. I push against the other side of the table with a force of 600 newtons. The table has a mass of 80 kilograms. A, what is the resulting acceleration? And B, if we keep this up for 10 seconds, how far do we get? Fantastic, we've got another kinematic and forces equation, so let's make a variable list. S, xi, vi, vf, a, t, f, and m. Our equations are going to be f equals ma and s equals xi plus vit plus 1/2 at squared. Now in this one, I'm actually going to add a second force variable. I'm going to call one F1, the other F2. F1 is you, pushing at 500 newtons. Now let's go ahead and draw a free body diagram to look at this. So you're pushing here, 500 newtons. I'm pushing here with 600 newtons. For ease of calculation, I'm going to make your force negative. So our resulting force, our F net, is going to be the addition of those two forces. 600 plus negative 500 is exactly 100. So F1, that's you, negative 500, sorry. F2, that's me, is 600 newtons. And F net is going to be 100 newtons. Now, we know the table has a mass of, what did I say, 80 kilograms? And we know that we're going to push it for 10 seconds. So, first, we want to know what is the resulting acceleration. Well, very simply put, that's going to be F net equals ma. Well, I've got 80 kilograms for m. I've got 100 newtons for my net force. So my table is going to accelerate this direction based on a force of 100 newtons. Doesn't matter that this is 600, it doesn't matter that this is 500. They're going to oppose each other and cancel out a total of 500 newtons, leaving me with 100 newtons left over to determine my acceleration. Okay? It's very important. We are adding these forces together. One is negative, they are opposing forces, so they are canceling each other out for the most part. So, F equals ma. F is 100 equals m, which is 80 times a. So 100 divided by 80. It's going to get me 1.25 meters per second squared for an acceleration. All right, and then we're going to plug that right into our S equation. Our xi is 0, our vi is 0, just as we've been doing so far. I don't want you to take that for granted though, because there are going to be situations where we're moving. Maybe we have something that's already moving and we apply a force to stop it. So keep that in mind. Those aren't always going to be 0. They just happen to be 0 in the current problems that we're working on. So we're going to simplify this down to S equals 1/2 at squared. Looking for S. I have A, it's 1.25, and I have T, it's 10. 10 squared is 100, times 1.25, times 1/2, equals S. 1.25 times 100 is 125, and 1/2 of that, 1/2 of 125 is 62.5 equals S. So we travel 62.5 meters. Okay, and that was our resulting acceleration. Perfect. Thank you.